now we have David Vaskevitch, the founder at Gaia. Among David's first ventures was Plan Design, and then a subsequent venture, Standard Software, was one of the earliest venture capital-funded software companies in North America. Then in 1986, David joined a very small software company called Microsoft, where he held various senior executive positions in his 23-year service. Can you please give David a very warm welcome to the stage?
Okay, good afternoon. So I just want to ask, is the video going to run on its own, or do I need to start it? If I click this, okay. So I hope you perceive my talk as a little different than some of the ones you've heard before now. I'm specifically going to talk about decentralization. I'm going to talk about moving to a decentralized world. I've actually been writing software since 1966. When I started writing software, everybody who worked wore a suit. So in a way, I feel like I'm going back home when I come here, although I'm not wearing one myself. And I've lived through 4 or 5 computer revolutions, and each time the claim has been that this is the revolution that's going to democratize and decentralize the world, and it hasn't quite turned out like that.
Not all systems should. Over time, their frailties become apparent, and they're replaced with something better, easier, more resilient, and well-suited for the future. Today's internet is what happens when technology is a rush job. Each piece bolted onto the last in an architecture founded on principles first envisioned 40 years ago, appropriated and constructed to serve the few, not the many. But what if the internet of the future didn't have to be the internet of the past? What if we weren't afraid to dream that it could be decentralized, equal, secure, and constructed for all people, not just big people? Gaia is a Genesis event to reappropriate the ideals of true decentralization and collaboration. It's not 1984 anymore, and it never should have been. And while all successful movements need a leader, this time we need to make sure it's all of us.
So it's interesting to think about. For example, at the beginning of the PC revolution, we all had this idea that PCs would bring computers to everybody. And at the beginning of the PC revolution, there was this incredible fear about IBM. The Justice Department actually had brought multiple suits against them in the US, and there was also similar actions in Europe because of the amount of control that IBM exerted in a centralized fashion. And then I got to live through the same experience at Microsoft. People were terrified about Microsoft's central control over the economy and our lives. The ironic thing is that if we think about the amount of power that a small number of companies, Google, Amazon, Facebook, even Apple, and to some extent still Microsoft have, they make the degree of control that Microsoft and IBM had in the old days pale in comparison. And yet, we still believe that there's an opportunity to not live in a winner-takes-all world. And so what I'm going to talk about is what the internet would have to look like and how blockchain fits into that, what would be required to truly move into a decentralized world. So one of the things people puzzle about is understanding blockchain. You know, I've been working at it for a while, and like I say, I've been writing software since '66, and I've seen a lot of complex technologies come and go. I remember at the beginning of the internet era, working with Bob Metcalf at 3Com, and we were trying to figure out, many people were trying to figure out what the quintessential TCP/IP application would be. It turns out there isn't one. It turns out there is a thing called the internet, one level up, And once the internet became successful, TCP/IP became far more prevalent than anybody could ever have imagined. And so I read articles. I've probably read several thousand articles now, technical papers, articles, mathematical papers, and there's a particular genre of paper in which people try to figure out how the blockchain is better. And in this particular genre of paper, they keep talking about all the things the blockchain does and how centralized systems actually do those things better. I'm sure all of you have read those papers, right? And when you read one of these papers, they're often very well written, you expect them to have a kind of negative ending. So one of the best written of those papers actually appeared in the New York Times Sunday magazine about a month ago. And at the end, there was an interesting quote. In its potential to break up large concentrations of power and explore less proprietary models of ownership, the blockchain idea also offers a tantalizing possibility for those who would like to distribute wealth more equitably and break up the cartels of the digital age. The cartels are those companies I talked about before, as well as a few others. So here's another article where the author says this is why we have to make the blockchain work. And then he goes on to say that making the blockchain work means writing a new class of applications. He basically describes why if we don't write new code, we aren't going to get there. And I have two questions. One is, what kind of code are we talking about? Is it strictly tokens? Is it strictly new types of currency, or is it something broader than that? And my other question is, how is that code going to be written? So the other type of article that I've seen starting to pop into existence recently is the description of a thing called Web 3.0. So in this model of the world, Web 1.0 is the static display of pages. Web 2.0 is an interactive web in which we get to interact with central servers and order products and communicate with people and so on. And then there's Web 3.0, in which data is local and private. In Web 3.0, there's no central point of control. We have local presence and global reach. Software is personal, unique, and customized, and particularly the four things at the bottom. In Web 3.0, I'm in control. My community is my choice, not somebody else's. My computers are mine and they're my friends. I'm not dependent upon somebody else's server who can decide to kick me out at any time. And my software is mine. It's my software. I get to build it, I get to personalize it, I get to decide how it runs. Okay, that's great, but what does it mean? So this is our dream. This is the first time we're talking about, we're building a platform, but I'm not here to sell any tokens. This is not a sales pitch. You actually can't buy the platform anytime soon. This is a very ambitious project. For me, it'll be the 8th platform I've ever built. I built one of the first 3 email systems in the world in 1971. I wrote one of the first word processors in the world. They were called text editors in the late 70s. You know, I helped to make Windows and the Windows Office take off. I believed in graphical applications. I pioneered the concept of app servers and distributed transactions, and my partner, who's sitting in the back, we just thought it was too complicated to divide a presentation this short among 2 people, worked with Rivest and Shamir developing the early crypto algorithms. So we've been at this for a long time, and we know that even if things take a while, they can still really make big changes. So we have a dream of a world in which there are 100 million entrepreneurs. That means artisans and small businesses, not big companies. We have a dream in which applications run in the office, in vehicles, in stores, in clinics, and homes. They run everywhere. We have a dream in which the economy becomes community-based. We have a dream in which software can be written by normal people, not by some small cadre of priests working in big organizations. And most of all, we have a dream in which the future is not just for the few, it's for everybody. Now, one of the things that this dream depends on is a shift back to distributed applications. And so I'm going to describe 3 distributed applications, but first I'm going to tell you why there's no question in my mind that distributed applications are going to happen. Now, there's a pendulum that swings from centralized to distributed, to centralized to distributed. The beginning of the iPhone era with the App Store and so on was a swing in the distributed direction. The one thing that's going to make distributed really happen is smart machines. A self-driving car is not going to be powered by an application running on a cloud-based server. Or if it is, I don't want to get into it. When that self-driving car approaches an intersection, which at some time in the intermediate future will no longer have traffic lights, it communicates with all the other self-driving cars, not through a server in the cloud, but peer-to-peer. And so we are going to be in a world soon in which there will be billions of autonomous smart machines that is a very distributed world. And the platform required to make that happen, that same platform could make the kinds of applications that I'm about to describe possible as well. So for example, imagine that I want to buy a bicycle. And I hear about this bicycle builder in Wales. And so I communicate with him and he sends me a little app that runs on my phone, and I get somebody to hold my phone and watch me while I'm riding a bicycle. And he now has all the information he needs to custom build a bicycle that fits me perfectly and suits my riding style. So he designs the bicycle on his iPad, and he works with somebody who builds drivetrains in South America. That person gets some of the gears and other components he needs from somewhere back in the US. The bicycle maker also gets seats from a seat manufacturer, which is a 12-person company in Italy, who gets leather from one place and springs from another place. And so this is an environment in which there are lots of small computers everywhere, no central servers, all communicating with each other peer-to-peer. Those include servers that control the manufacturing process of doing some of the welding of the bicycle. It includes my computer talking to the computer in Wales. It includes the managing of the small business. The bicycle organization is 4 people. The drivetrain maker is 12 people, and so on. I'd love to be able to travel to a foreign country, walk into a medical clinic, and all my records are on my phone. They're mine. And my phone communicates with the computer in the medical clinic, and that medical clinic has an MRI which has a built-in diagnostic system, another smart machine. And then maybe I need a small procedure which is carried out by some kind of a small robo-surgeon. Those things all already exist. You know, over here you see an example of a robo-surgeon. And so this is another example of peer-to-peer communication. And then my last example is worldwide craft manufacturing. So the bicycle example was one. Perhaps the ability to make furniture is another. Somebody who makes jewelry is another. But the central concept here is very simple. Even today, in the US, which skews more towards large business than any other country in the world, 54% of the economy comes from businesses with less than 100 employees. Most of those businesses have less than 10 employees. If you want to do the 80-20 rule, Fortune 500 starts at about 5,000. That's 18% of the economy. And in the rest of the world, countries like Korea and all over the world, small business is an even larger percent of the economy. But we're talking about those businesses now being able to be as effective as a big business. So a lot of people picture the blockchain as playing a central role in making that happen. There are 2 issues with that proposition if you're literal about the blockchain. The first issue is that the blockchain itself, the concept that there is a single chain of blocks, that every computer that's a participant receives the entire chain, that is the center for the world's economy, not just financially, but in every other way, supply chain, medical records, everything else, implies that, for example, my phone, my personal computer, no matter how small it is, needs to be able to hold all the credit card transactions, not just for today, but for all of history. Wait, not just the credit card transactions, all the medical information, all the supply chain information. How is that going to work from a bandwidth perspective, from a computing perspective? There's something wrong with that picture. But the problem goes deeper. The blockchain is one piece, but in all those examples that I talked about, even if this worked perfectly, how do those machines all find each other? How do they communicate with each other in a seamless fashion? What kind of a database do those machines use to store all the information we're talking about? A self-driving car, for example, collects over 10 terabytes of data on a typical day. You know, that small business that's doing all the manufacturing actually has a huge amount of data. And then when you think about what the database is that runs in a phone, the phone that my iPhone 10 is 30 times as powerful as the biggest internet server in the world in 1998, the year that I rolled out the first SQL server with record locking. And yet the database that I run on it, SQLite, isn't even client server. Like, database is now 60 years out of date, and that's what we're writing all of our applications on. Worst of all, applications are getting harder, not easier to write. If we made a list of all the programming languages in the world, with 2 exceptions, all of them were invented in the 90s. So it is the golden age of hardware, and in many ways, the dark ages of software. So what's the alternative? Let's start with, we need a platform that has a distributed fabric. So this distributed fabric, we're talking about an open source platform. We're talking about what is the platform that makes the decentralized world really possible. We call that platform Gaia. So I'm not going to go through all the details, but one thing I will say is it will have 2 characteristics that are unique. Designed from the ground up to be secure. There is no platform in the public world, the non-military world, in which security wasn't bolted on after the fact. I don't know about you, but that makes me very uncomfortable. The other thing is that this is the first network platform in the world designed from the ground up to center around a mesh architecture, peer-to-peer worldwide. Next, we get the database. Now, one of the things that makes almost everything that we count on in computers possible is the unbelievable amounts of memory that we have available to us. So database technologists have known for a long time that if you build a database to be memory-centered, it will be millions of times faster. So SAP, for example, built such a database just for their enterprise customers. It's called HANA. It was built by a friend of mine, the founder of SAP. So UPS came in to test the database, and they sent him a big data set, and they ran a query that normally takes 4.5 days to run in a normal database. It finished in just under 4 seconds. This is the kind of performance that we need to have intelligent applications that interact all the time. But more importantly, this is a database that's designed intrinsically to run everywhere and to be distributed and fault tolerant. Now, if you had those 2 pieces, then you could build a generalized transaction system. So when we read all the papers about sharding and sidechains and RAIDing and Lightning, these are all very impressive technical discussions. It's particularly interesting reading about RAIDing because the problem is so complicated, they still haven't had the time to write the white paper. And the problem is that we're starting with the wrong conceptual foundation. The correct concept is that the world needs a generalized transaction system. This is a well-known construct in the computer science world, and so one of the central components in the Gaia platform will be a generalized global transaction system. And yes, there will be a token. I don't expect there will be an ICO because this is not really about fundraising, but there will have to be, by definition, a genesis event. The interesting thing about this token is it becomes the fundamental underlying, I love the word gas. When Ethereum invented that term, I love it. The fundamental underlying gas that comes into play whenever 2 computers or 2 applications interact and make agreements with each other. Those agreements could be financial, and they might not be financial, but we're talking about a token, and there will be probably 5 orders of magnitude more of these tokens than any token we know of today. And that still won't be a large number when we think about powering the world. And now the last piece, programming. Why is programming so hard? Once upon a time, spreadsheets were really hard. If you wanted to do financial planning, you had to be a programmer. And then Dan Bricklin invented the spreadsheet, and nobody even remembers those old programming languages. Once upon a time, if I wanted to do a presentation like this, I hired a graphics artist, paid $5,000, and got a set of 35mm slides. And then PowerPoint came along. Nobody even remembers those days anymore. Now, back in the 60s, when I was just starting to program, artificial intelligence was a new thing. And there were 2 main schools in the artificial intelligence movement: machine learning and rule systems. And they were complementary. They sort of went hand in hand. And the interesting thing is, because AI is such a broad challenge in general, it goes through summers and winters. So I left Microsoft around 2009, and I had half a dozen machine learning projects. And every day, almost, I'd get told off for betting on a technology that was known that it couldn't work. Like, everybody knows neural networks can't work. And then neural networks came out of their winter. Now, one of the characteristics of neural networks is that there are classes of problems, like translating one human language into another, recognizing faces or pictures in general, broad classes of problems in which you have 2 choices: write millions of lines of code, or let the machine learn how to recognize the patterns. So the broader concept is that machine learning replaces types of programming we no longer have to do by hand. And the same is true of rules engines. We believe that in this world of the future, when that bicycle manufacturer is deciding on what conditions he'll take your order, and when the frame should be bigger or smaller, and when the right metal is titanium versus carbon versus steel, he will be specifying the policies and the rules himself. I call it code-free programming. And we know, because rules engines have been through the same summers and winters, that used effectively, a rules engine can allow domain experts, people who know the business, to write applications without depending on programmers about 10 times as fast as if they tried to get somebody else to write the code for them, and without the need for that code. So that's the whole picture. And what we believe is that this is sort of the, minus the formatting problem, we believe this is sort of the minimum possible requirement. It's an ambitious platform, but platforms of the past have been ambitious before. This is what it would take to really move to a decentralized world with 100 million entrepreneurs, applications running everywhere, and putting us back into our control, in control of our own data and our own applications. So we're busy building this. We're starting to assemble a team. We have an early version of the platform already running. And we see this rolling out over a 4-year period of time. And we're actually at the New Alchemy booth in the back of that room. So if you have questions or want to give us feedback, we invite you to come back and catch us before we take off. Thank you very much.